Hello everyone and welcome to today's session on Java Collections Framework webinar. So today we are going to discuss about sets. Now those of you who have joined me in the previous sessions, you know that we have so far discussed collections and collections class, and we have also talked about array list, linked list, vector and stack, right? Now in this session we'll move on to another implementation of collections, that is a set. So all these are derived from collections interface. So we have java.util.collections interface, part of which is our list, our set and our map, right? Now we have seen the detailed implementation and interface in class hierarchy in the list section. Now today we'll move on to set. We'll see what set interface does for us, and we'll see different implementations of set. Now there are 4 of those. We'll take a look at all 4, and then we'll move on to 2 more types of set interfaces that help us achieve some different functionality. So the point of having so many collection classes and so many collection interfaces is that we can strictly define and decide that okay, this particular collection helps us achieve so and so details, so and so properties. Now this set, if you want to implement so and so functionalities, you go and opt for a set. If you want to implement an unordered list that you want to access as the way you entered the data, you go for a list. And similarly for certain features you opt for map. Now the only thing that you need to be aware of when you are dealing with collections framework is what all functionalities are provided by each and every individual collection. Okay, and that is the knowledge that if you have will help you get a deeper understanding of where which collection has to be used. Now most of the interviews or the written exam, if there are any questions on collections, most of them focus on checking whether you are able to differentiate between one collection from the other. So if you are given a set of data, okay, we want to implement this, you should be able to decide out of the 3 options that whether you want to use an array list, or you want to use a sorted set, or you want to use a hash map, right? And that comes only when you are aware of all the properties that are there in all these collections. So this webinar will walk through one by one, like we have seen lists so far. We'll today check sets, and we'll see the different properties of different set implementations, how they are different from each other. All right, so at any point of time, if you have any doubt, you can post on the comments, both YouTube and Facebook. All right, and let's quickly jump onto the session and see sets today. So browsing through quickly for what we have seen so far is collections framework, that is java.util.collection class, some methods that are inherited by all the implementations, either be it list, be it a set, or be it a map, correct? Then we have collections class, which is a utility class. Then we have synchronized versus concurrent collection. Then we moved on to list and array list and linked list, right? We saw vector, what is a vector? We saw stack, how do we work with stacks? And now finally we'll move on to set. But before that, let me see who all have joined so far. Dharmendra, Ashok, Sangeet, Dinesh, Madhav Rapu, Binay, Vikram. Hi everyone, hello, good evening. And Binay, don't worry, you're not late. We have just done a quick recap of what we have seen so far in the series, and now we'll start off with set. Hi Amir, Vikram says please speak slowly ma'am. Okay, we'll do that. All right, on Facebook we have Suraj, we have Nagesh, and we have Banish. Okay, hello everyone, and let's move on to the session. Amir says maps please. Amir, map is also part of this 7-day series, so we'll see map in one of the later sessions. Today we'll talk about set. All right, so as you see, set is also one of the implementation of collections. So let me quickly draw the hierarchical diagram for you. So this is java.util.collection, right? And we have seen list, which has array list. I'm just writing the short form, okay? Linked list, vector, and stack. Okay, and now we are on to set. So set is another interface that we have in our class, and if you see the simple code that I have here for creating a set, okay, we have set A, where we are calling hash set. We are creating a hash set basically, and we add one element, that is element 1, created one string element, added it to the set using the add function, and finally we are printing out that whether the element is present in the set or not. So what contains function is doing, it is checking whether this particular element is present in set A or not. All right, fairly simple implementation so far. So what a set basically does is it represents a set of objects in very literal English form. Now, if you are implementing a set of object, there are no duplicates in the set. So any situation, like in list there could be duplicates, but in set there are no duplicates. So any situations in the program where you want to represent a collection of data, a set of data that has no duplicates, you go for a set. Alright, each element in the set can exist only once. Okay, Sai Bharat just asked me, ma'am, I had a question, when we need to use set interface. So Sai, I think I just answered your question. We use it when we want a set of data where each element is unique or each element comes just once, right? Now since this is an interface, we need solid implementation classes to use, like hash set, right? And other than hash set, we have more implementations for different needs. So one is enum set, one is hash set, one we have is tree set, right? So let me quickly move on to the next. Yeah, enum set, hash set, linked hash set, and tree set. These are the 4 classes which you can use to implement a set interface. Amit says list has duplicates. List can have duplicates. You can add duplicates into list. It will not block you from adding, but in set you cannot add duplicates at any point of time, right? Now let's take a look at a detailed implementation of each of these. Now what is enum set? If you are familiar with enum, this will become very simple. Enum set is specialized implementation of set interface which deals only with enumeration data type. Okay, you cannot have any other data in enum set other than enumeration type. Okay, now what is enumeration type? What is an enum in Java? Enumerations are types, data types present in Java that serve the simple purpose of representing a group of elements. Let's say, for example, you have to represent the suits in the card game. You are implementing some form of card game. You have to represent the suit in card game. Okay, so you can create an enum called suit which will have 4 unique elements, right? What are the suits in the card? We have club, we have spades, we have diamond, right? And we have heart. Okay, these are the 4 suits in the cards, right? Now if you create this enum with these 4 data, this enum then can be used to create a enum set. Okay, so enum set is the implementation of set which only uses enumeration data type. Only an enum data type can enter into it, right? Or let's say, for example, let's say we have color. Okay, we declare an enum color. Let's say we add three colors that we like: red, blue, black. Okay, this is our enum. Now when you have to create a enum set, you are going to use this particular enum to create the enum set, which again is fairly simple. All you have to do is say set, let's say dummy is equals to new enum set, right? Like any other, like you create list, or you create a vector, or you create a stack, creation of enum set is also simple like that. Okay, that's what enum set does. Now more details, if you are looking for in an enum set, what it does, what it is useful for. So enum set class again is a member of collections framework, and it is not synchronized. Okay, and it is high performance set compared to hash set or linked hash set, because we have limited it to a certain type of data. Now all elements of each enum set instance must be elements of a single enum type. You cannot have elements in this enum set from this enum type as well as this. A combination of two enum type will not work. All elements in one enum set must be element of a single enum type. So if you have created an enum set that is using this, all elements will be this. If you want this, you have to create another enum set to use elements of this. All right. Now moving on to next, hash set. Now this is another different implementation of a set. Again, since it is a set, it has no duplicates, but the way the data is organized is different. So this hash map works on hashing technique. Now what is the main point for a hash set is that there is no guarantee about the sequence of elements when you iterate through a hash set. So let's say in a hash set you entered the data 20, 15, then you enter 1, then you enter 12, then let's say you enter 55. All right, this is the order in which you entered the data in your hash set. But when you iterate through the hash set, let's say you write a while loop to iterate through the elements of your hash set. Now the order in which you get the output from your iterator can be different from this. You might get 1, 12, 15, 20 and 55. That is the main point of a hash set class. There is no guarantee about the sequence of elements when you iterate over them. Like in linked list or in let's say array list, whatever order you enter the elements into in a linked list or array list, that order is maintained. Okay, now in hash set that doesn't happen, that order is not maintained. Now if another implementation that you see, that is linked hash set. Now since it is a linked hash set, it implements linking. So the order during iteration is maintained in linked hash set. So if you want to run any implementation of your program where the order of insertion of data is maintained, you go for linked hash set. All right, and finally tree set. Now where do we use tree set? Again, set, so unique elements, but where do we use it? If we want our element to be in sorted order. Okay, that is the case where we use a tree set. Let's say you entered all these elements only 20, 15, 1, 12, 55. A tree set will give you these elements in sorted order, and by default the sorting order is ascending. So you will get 1, 12, 15, 20 and 55. This is the output of tree set, and this is the output of hash set. All right, that's essentially the difference between all these four set implementations: enum set, hash set, linked hash set and tree set. Okay, and there are concurrent implementations also of set. So if you remember, concurrent implementation, by that we mean that if we have a set of elements and we use a thread to access some of the elements, concurrent implementation will give us a set of data to access for thread 1. Now thread 2, if it wants to access some data in this, it will create another set for thread 2 to access. So that is concurrent implementation, right? Now set implementations also come in concurrent classes. And again, if you in tree set, one more point I would like to mention is by default the order is ascending, but if in your program you want descending order, then you can create descending order also. How do you do that? You simply say tree set dot descending iterator. So that will iterate in descending order. Now this will give you elements in descending order, that is 55, 20, 15, 12 and 1. This is the order in which you get a tree set when you call a descending iterator over it. Alright, so I hope so far we are good and clear on this. Let me quickly check if you guys have some doubts around the same. So Dharmendra is asking, where is collection class used here for creating set? Well, Dharmendra, collection first off is an interface. It's not a class, java.util.collection. As we saw here, right? Java.util.collection, this is an interface. Now set is another interface which is a subtype of collection. So the sense in which collection is used here is all the methods that are generic to this collection interface are by default part of set, and enum set, hash set, tree set and linked hash set, right? So that is how you implement generalization and specialization, correct? So all the methods that are common to all these interfaces are part of the collection interface. Then all the methods or functionalities that are common to all the sets are part of the set interface. And then specialized implementations are part of these individual classes. Now these are all classes. Okay, enum set, hash set, tree set, linked hash set. Okay. Monica just joined us. Hi Monica. Dinesh is asking, what is the meaning of non-synchronized? By non-synchronized I mean that more than one thread can access the set. Okay, if it is synchronized, only one thread can access a particular set at a time. If it is not synchronized, multiple threads can access the data. Pawan says enum is a user defined variable which is used to add list of elements. Enum is a user defined variable, that is correct, which is used to not add, basically it is used to keep a list of unique elements, I would say. So if you have this color, or let's say if you know that in your program you would need the suits, right, in a card, and you know that there are only 4 types of suit in a card set. It is club or spade or diamond or heart. There is no 5th type, right? So you create a enum suit to check, okay, if there is a suit, it should fall between these 4 types. It should not go out of it. So for things like that, or for other implementations, we create a enum when we know that, okay, this defined set of data should be present for this particular enum. Vinay is asking, ma'am, can we do sorting in hash set? Yes, we can do sorting in any of the collection interfaces. We'll discuss sorting in more detail in another session, Vinay. I'll not take it up right now. Dharmendra says, will output of hash set be same if we traverse it 2 times without making changes? No, it could be same, it could be varying. You cannot decide the output. All you can do is enter the data. Now the output every time you run could vary or could be the same. That you don't have any control over, and that is how hash set is implemented. Okay, Amir is asking, why doesn't it follow sequence. Amir, it doesn't follow sequence because behind the scenes a hash set, what it does is it uses the hashing technique to store data into the map, into the set, right? And based on this hashing technique, or since it is using the hashing technique, the way in which the data is retrieved when you want to retrieve it becomes quite different. Hashing is another detailed topic on its own, but to answer your question, the reason why it is not in the order in which it is inserted is because it uses hashing technique to store the data. Linked hash set. So linked hash set is fairly simple out of all the four. Madhav Rabbu asked, right? Yeah. So linked hash set is the simplest of the four in the sense that it uses the simple linked structure to add the data, and let me just add it right here for you guys to look back later. Linked hash set gives us ordered output while iteration. So if you insert data in this order, the output will also be in the same order. When you want the order to be maintained while using a set, you use a linked hash set. Okay? And tree set simply just sorts your data. In hash set, insertion order is not preserved, and linked hash set insertion order is preserved. That's right, Mahesh. Can you use comparator for customized sorting? Yes, you can use comparator for customized sorting for any of these sets or linked list or any collection class that you would want. Okay, Devbrat says, can we have a quick revision of what you taught till now? I was late. Devbrat, that's okay. We'll quickly walk through. We simply discussed that we have set interface, another interface that is part of collection. There's one called list, there's one called set. In list, we have array list, linked list, vector, and stack. In set implementations, we have enum set, hash set, tree set, and linked hash set, right? And then we saw this short program, how to create a set and how to add element into the set. Then we saw the use of contains function to check whether an element is present in a set or not. And then we moved on to set implementation. So enum set is used for enumeration data type. Hash set, it doesn't maintain the order in which you insert the data. Linked hash set, it gives you ordered output. The way in which you order the data, that is the way in which you get the output when you iterate through. While tree set gives you ascending order output. So if this is the data you have inserted, the output for tree set would be 1, 12, 15, 20, 55. Okay, and if you want to go in descending order, you call the descending iterator on a tree set. So this is what we have discussed so far. Okay, now moving on to the next slide that we have, that is sorted set. Okay, now sorted set is another interface which is part of set. So if I would have to design it in hierarchy right here, I would say sorted set is another interface and tree set is the class that implements this sorted set interface. Now what happens in sorted set is that the elements are sorted internally and the class is java.util.treeset. So if you want to maintain a sorted set, all right, you go for java.util.treeset. Okay, and similarly, if you want to go for a navigable set, there's one more type of set interface called navigable set, which is again implemented by treeset. Okay, so navigable set, what it does is it obtains the navigation order, the navigation methods. There are certain methods that are provided by this navigable set interface to iterate over through our sets, right? Let's quickly take what I have listed here are few of the most commonly used methods of navigable set. Now, navigable set and sorted set are both subtype of our set. So the set interface, sorted set is a subtype of set interface, and navigable set is a subtype of sorted set. Okay, this is the hierarchical order of set, sorted set and navigable set interface. So navigable set behaves like a sorted set, but with the exception that you have these navigation methods. Now, these are not the only methods, there are more, but these are the commonly used navigation methods available in addition to the sorting mechanism provided by the sorted set. Okay, now what each of these navigation methods do, let's take a look. Let's say we create a navigable set. Let's say ns equals to new. Now, only implementation that is there for navigable set is tree set. So we say new tree set. All right, and let's say we add 3 elements into it. ns.add 1, ns.add 2 and ns.add 5. Okay, we added these 3 elements. Now, what headset does is the headset method returns a view of the original set which only contains elements that are less than the given element. So if you say you want headset, you create a headset. So you say navigable set, let's say HS, that is headset, is equals to original, or in our case we have navigable set ns, right? So you call ns dot headset method. Now in this headset method you pass the value 3, let's say, and true. So what the headset does is it gives you a set, a navigable set again, which contains elements that are less than the given element. So what elements are less than 3? 1 and 2, right? So our headset that we have created will have 2 elements, 1 and 2. Similarly, if you do a tail set, if you create a tail set by doing ns.tailset, what it will do, it will give you elements which are greater than the element that you have specified. Okay, so when you say 3 and you have the same list, you're calling it on ns, right? Ns has 3 elements, 1 to 5. Tail set will give you elements that are greater than 3, that is only 5 in our case. So tail set would add 5 to your list. Now what does subset do? Subset will give you a subset of your list. Now when you're calling subset, you want to give 2 values, so it will give you value set between the 2 values. Let's say 3, right, true, and 8, true. Okay, this is the implementation. Now what this will do is the subset implementation will give you all the values between 3 to 8 in ns and assign it to this new subset that we have created, okay, which is 5 again, right? Now moving on to the next two, ceiling and floor. Ceiling method returns the least element in the set that is greater than or equal to the element passed as parameter to the ceiling. So if you say let's say ceiling 2, okay, you say ceiling 2 and you pass this function on ns.ceiling2. Ceiling will give you least element that is greater than or equal to the element passed. So since our navigable set has 2, the output will be 2. Let's say if we do 3, if it is 3, our set doesn't have 3, so the output will be the least element that is greater than 3, that is 5. correct? Similarly, floor function does the opposite of ceiling function. It will give you the least element in the set that is greater than the element passed as parameter. Okay, so if we do ns dot floor 3, right, you'll get output 2. Cool. The floor method just does the opposite. So when you say ceiling and pass this value, any element that is greater than, or if you have 3, it will return 3. If you don't have 3, the very next element that is closest to 3 and higher will be returned, that is 5. And if you do floor, the very previous element that is lower will be returned. This is the simple implementation of these 5 functions. All right. Okay, moving to the questions that you have. Does linked hash set implement hashing techniques? No, only hash set implement hashing technique to store data, Amir. Binay is saying, if set don't maintain order, please provide exact reason why tree hash set is maintaining order. That is the reason, Binay, why we have different implementations. So the whole function of having a point of having a set is that we want to have unique set of elements represented by this collection interface, right? So be it hash set or enum set or linked hash set or tree set, all these classes would have unique elements. They cannot have duplicates. That is the one functionality for which sets are used, because they don't have any duplicates, right? Now, apart from that, that is the common functionality for all the sets. Apart from that, all these sets have some unique characteristics for which we prefer one over the other, right? That is the reason why we have tree set, to get us ordered. Now, if you want a set of data which should have unique elements but should be ordered, so we added a tree set class. You want a set of elements which has unique elements but only targeted to enum. We made enum set. Okay, so different implementations have different uses or characteristics to it, but the common set implementation characteristic, set interface characteristic, is that it represents set of objects which are unique. Each element can exist only once in a set. All right. Dharmendra is asking, why did you pass second argument as 3 in head set and tail set, etc.? Okay, let me go back to the slide. This 3 I have just taken as a reference. If you say 2 here instead of 3, right, headset will give you the list of elements that are lower than 2. Okay, 2 and lower than 2. So in that case, we'll get 1 and 2, correct? If you have, let's say, 5 here, or let's say if you have 7 here, tail set would give you elements that are greater than 7 in the set, which are none. So now in this case, tail set will become null. 3 is just a parameter. You can use any parameter you want. The idea is that head set would give you elements lower than the parameter you pass. Tail set would give you elements greater than the parameter you pass. And subset will give you elements between the two parameters that you have passed. Alright? That is the simple logic of giving 3. The 3 is just any parameter that I have given. You can use any other parameter that you like for this. That is obviously should based on your program requirement, etc. I just had added 3 elements into the list in my example, so I used 3 to show you that if you have 3, headset will give you 1 and 2, that is lower than 3. Tail set will give you 5, that is greater than 3. All right. Okay, so that was about sets, guys. We saw set interface. We saw 4 implementations of set interface, that is enum set, linked hash set, tree set. We also saw what a sorted set is and what a navigable set is. Now remember the hierarchy. We have collections, we have set, we have sorted set, and we have navigable set. Okay, this is the hierarchy of all the interfaces, and sorted set and navigable set are both implemented as tree sets. Okay, only one implementation of both these interfaces is present, that is tree set. So that was about sets. I hope set and all its functionalities and all its implementations are more clear to you by now, and we'll meet in the next session tomorrow at 7 p.m. again with another topic, another collection discussion.